Hey guys, Dr. Brown here, and tonight we're continuing studying on using trig functions in integration. So we have the integral of tangent to the fifth of x over 2 dx. Now, you'll recall in the previous video we went through where some of these Pythagorean identities come from. For example, if you have a unit circle and you create an angle called theta, and then we strike a line perpendicular to that line that we've created here and let it run down till it hits the x-axis. But if you trig that out, you end up with that length of line is tangent theta. So tangent squared plus 1 squared equals the secant squared, okay? So we're going to utilize that concept, that one here tonight. All right, we have tangent to the fifth. I may be a little off the screen, but that may make the video better. All right, the integral of tangent to the fifth, x over 2 dx. I know that the derivative of tangent is secant squared. I also know that tangent squared equals secant squared theta minus 1. So let's use that. And that's right off of that triangle. All right, the other thing I'm going to do is let's go to the u world real quick. All right, let's let u equal x over 2. du equals 1/2 dx. 2 du equals dx. Now you may have to zoom in as I'm doing this. I'm writing a little bit smaller tonight so I can get all of this on the board. Okay, having said that, I have the integral of tangent to the fifth of u du, or 2 du, that was my dx. Now then, let's take tangent square out of this. I have tangent cubed u times tangent squared u du. That would give me tangent to the fifth, okay? Now, the logic here is if I can introduce a secant squared into this, I can let u, or I've already used u, but you get the idea. I'll call that t. I'll let t equal tangent. And it would be t to the third power, and then I'd have a du over here if I can introduce a secant squared. And I can do that in this case. So 2 times the integral of tangent cubed u times secant squared u minus 1 du. Now let me distribute this to the inside. So now I have the integral of tangent cubed u times secant squared u. I'm going to create a couple of integrals here. Minus, take care of this, 2 times the integral of tangent cubed u times this 1 du. Now I accounted for the negative right here. Now I did this video earlier and I lost this 2 somewhere along the way. So I'm repeating it. Okay, all right, now I have, if I let u, well, I can't use u anymore. Let's let t equal tangent u. dt equals secant squared u du. Secant squared u du. So all of this right here is dt. And this is u cubed. So now I have 2 times the integral, not u cubed, but t cubed, of t cubed dt. That's dt, secant squared u du, and tangent is t cubed. All right, I took care of that one. In this case, let's take another I have tangent u times tangent squared. So tangent u times tangent squared. But I'm going to change that tangent squared to secant squared u minus 1 du. Now let me distribute that to the inside. 2 times the integral of tangent u secant squared u du. Negative 2 and a negative 1 gives me a positive 2 times the integral of tangent u du. Alright, so this scenario is exactly what I had here. So I have minus 2, the integral of t, and all of this would be dt, t dt. Now what do I have in this case? I have plus 2 tangent is sine u over cosine u du. So let's let t equal cosine u. dt equals minus sine u du. So dt over minus sine u equals du. So I have plus 2 times the integral of sine u over t, and then dt over a negative sine u. So those cancel, and I'm left with, I have this negative, so this becomes a minus 2, the integral of dt over t. So let's put all these together. I have 2 times the integral of t cubed dt minus 2 the integral of t dt minus 2 the integral of dt over t. All right, what did that give me? 2 times t to the 4th over 4 minus 2 times t squared over 2 minus 2 times the natural log of t. All right, t to the 4th over, well, this would be t to the 4th over 2. T to the 4th over, well, 1/2 t to the 4th. Sometimes I really get sloppy when I get down to the bottom of the board. Let me just go up to the top. So 1/2 t to the 4th. Minus, these 2's cancel, that would be minus t squared minus 2 natural log t. Absolute value of t. All right, so what is t? T is tangent u, but what is u? X over 2. So I have 1/2 tangent to the 4th of x over 2 minus tangent squared x over 2 minus 2 natural log of t, which was tangent u, tangent x over 2 plus c. Okay, that, my friend, would be how we could take and utilize a Pythagorean identity and perform that on this tangent to the 5th x over 2 dx, result in 1/2 tangent to the 4th x over 2 minus tangent squared x over 2 minus 2 natural log tangent x over 2. That's the absolute value of that plus c. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying, guys. Just keep working problem after problem, and eventually you'll break through those barriers that are preventing you from getting to where you want to be. It's just like playing basketball. We don't shoot free throws and then when we hit one, we quit and say, wow, we got that. They say that's the difference between professionals and amateurs. Amateurs will practice until they hit one or two, and then they'll stop. Professionals will keep shooting until they can't miss. There's a big difference. So we want to keep working and working until we just can't miss. Okay? All right, that's all for now. We'll talk to you next time. Thanks.